All right, we're back. We're on page 7 of notes 20 of Calc AB. This is the last page. So they're kind of reviewish or like see if you really got it type questions. So let's see if we can dive in and do them. So the graph of f is shown in the figure. The shaded region A has an area of 1.5, and the integral from 0 to 6 of f of x dx is 3.5. Use the information to find each of the following. So the thing that like strikes me about this given information is that A has an area of 1.5, but that is not the definite integral, right? So what that's telling me is that, because the top curve is actually 0, so that's really telling me that the integral from 0 to 2 of 0 minus f of x is equal to 1.5. That's like the only thing that really strikes me. And then 0 to 6 is the definite integral. So there's a little bit of negative and then a little bit of positive, and then the net sum of that is 3.5. All right, so I need to find the integral from 0 to 2 of f of x dx. Well, I mean, I just wrote this. So, I mean, like, this is kind of overthinking it, perhaps. But, you know, this gives you the negative of the integral from 0 to 2 of f of x dx is 1.5. So the integral from 0 to 2 of f of x dx would be negative 1.5. Or you can just look at it and be like, oh, it's below the axis, so it's negative 1.5. Either of those, doesn't really matter. From 2 to 6 should be 0 to 6 minus 0 to 2. So 0 to 6 was given, and it's 3.5. Minus, we just figured out 0 to 2 is negative 1.5, so that is, I think, 5. 0 to 6, the absolute value of f of x, so this, we would have to do the integral from 0 to 2 of the negative of f of x plus the integral from 2 to 6 of f of x dx, right? Because we're below the axis, so you have to reflect it up like that. All right, so I think we know these values. So this is the negative of 0 to 2, so 1.5 plus 5. Plus 5 should be, I think, 6.5. I mean, 1.5 plus 5 is 6.5. I think that's right. 0 to 6 of 2 plus, so let's do 0 to 6 of 2 plus 0 to 6 of f of x. All of these feel like they could be multiple choice questions on an AP exam, to me, in my brain. All right, so the integral of 2 from 0 to 6, I think there's a rectangle that has a height of 2 and a base of 6, so 12. Or you can fundamental theorem it. Plus 0 to 6, we just found, no, 0 to 6 was given, it's 3.5. 3.5, so I think 15.5. Negative 2, I don't know, this is just negative 2, the integral from 0 to 2 of f of x dx. A lot of stuff predicated upon getting A right. And if you did, you're in luck. And if you didn't, you got to hope the person grading it is generous. And really, you really have to hope they're generous. Like, don't feel like you're entitled to any points. You got A wrong. So like, if you then base everything on that, it's like, you just didn't know what you were doing. All right, average value of f over the interval. Average value is integral over the interval. And so 0 to 6 was given as 3.5. So I'm going to say it's 3.5 over 6, but that's gross. So I'm going to make it 7 over 2 over 6. So 7 over 12. All right, that is a good problem. A lot of review concepts. The one little tricky thing maybe where we were told area and not the definite integral, but I think we managed to blow right through that. So let's take a look at this next thing, review. All right, so answer each part exactly or correct at 3 decimal places. We're going to try for exact, and if it gets too onerous, we will go 3 decimal. Or maybe it's only possible to do 3 decimals. Who even knows? All right, so I'm going to start with a graph. So we need the region, the area of the region R. Region is bounded by this, and the x-axis. So for this, I need 3x plus 1 to be greater than or equal to 0, which means that I need x to be greater than or equal to negative 1/3. All right, so like -1/3 and 5 and there, I guess. Okay, so when you plug in 5, you get the square root of 16, so 4. I don't know if that's relevant, but whatever. Okay, so area of the region. We're going to do the integral from -1/3 to 5 of square root of 3x plus 1 dx. All right, I like to do these without actually doing a substitution, so there should have been a 3 here, so a 1/3. So we're going to get 1/3, and then it's like u to the 1/2, so it's 2/3. So, well, it's u to the 1/2, so it would be 3/2 is the exponent, but 2/3 is the coefficient. 2/3, 3x plus 1 to the 3/2 from -1/3 to 5. Okay, so that's 2/9. And then when you plug in 5, you get the square root of 16 is 4 cubed is 64. And when you plug in -1/3, you get just 0. And that's pretty nice. You get 128/9. I think that's my answer. All right, should probably check it. I'm not going to check it. Whatever, we'll just do it. All right, find the value of h such that the vertical line x equals h divides the region R into regions of equal area. All right, so this one we definitely can do. I'm going to say that the integral from -1/3 to h of the square root of 3x plus 1 is half of my previous answer. So I'm going to say it's 64/9. All right, so this, if you remember, there should have been a 3, so a 1/3. So we get 1/3. There shouldn't really be an equal sign here, I guess. I don't know. 1/3, 2/3, 3x plus 1 to the 3/2, and it equals 64/9. Let's go up here. 2/9. So we can just cancel the 9s in the denominator, I guess. Oh, I forgot bounds. -1/3 h. So 3h plus 1 to the 3/2. Plugging -1/3, it zeroes out. Awesome. That's the best. 64/9. 9s are gone. 3h plus 1 to the 3/2 is 32. To the 2/3, 3h plus 1 is 32 to the 2/3. Cube root of 32 is not nice. And also, I don't offhand know 32 squared. So nothing, I'm going to leave that. So subtract 1, divide by 3. I'm going to say that h is 32 to the 2/3 minus 1 divided by 3. That's what I think it is. We'll find out. On the value of k such that the vertical line x equals k divides the region into 2 regions such that the area of the region from -1/3 to k, so that's like on the left, exceeds or is bigger than the region to the right by 1. So this is pretty much the same problem we did. Not a marker. So we have kind of like this region. This is 5, -1/3. And then, so I don't know, maybe this is k. So the integral from -1/3 to k of the square root of 3x plus 1. This seems like a calculator problem. Like, I think we could probably do it without a calculator, but I definitely don't want to. 3x plus 1. And then I'd have to add 1 because this is bigger, right? This is the bigger one. So to achieve parity, to make them equal, I would have to add something to this one. So I add the 1 unit that is the difference between them. I'm going to use a calculator on that, 100%. And then also, I'm going to, oh yeah, check the previous answers, I guess. So the problem with checking the previous answers is if I got A wrong, I got B wrong. So f of x is the square root of 3x plus 1. So integral f of x, comma x, -1/3 to 5. Okay, all right. What should I solve? Integral f of x comma x from negative 1/3 to k equals half of that, so 64/9 for k. All right, what is 32 to the 2/3? All right, same answer, nice. And then what I want to do is I want to solve, I'm just going to borrow this, the integral equals the integral from k to 5 dx plus 1. And we want to solve this for k, and we need k to be between negative 1/3 and 5. So I'm going to write that down and say that that's, so therefore k equals 274 to the 2/3 minus 4 over 12. I feel like we could have done that by hand. Like, that seems like something that we're capable of doing, but also it seems like maybe better not to do it by hand. All right, let's see. Let's go back. You can take a look at these. And then we are done with these notes. Very exciting. Next set of notes, I think probably going to be about volume. Volume's a big deal. Not hard, but a big deal. It comes up a lot. So these are the answers that I got, and we're done. So I will see you in the next video. Yeah, that's it.